Hello and welcome to the video which starts chapter 15. It's another video on probability rules, and it's just an extension of what we learned from the last chapter, okay? But we just go a little more in depth. So here, let's do a little review. If two events are disjoint, that means that the outcomes, if that's one event, the outcomes in one event do not have any outcomes in another event. Okay, so they do not, there's no overlap. Okay, this is empty. Let me not draw a circle. This is empty. Okay, so we learned if they're empty, then the probability of A happening or B happening equals just the sum of the two probabilities. Okay, so now we're going to say, well, what happens if they're not in disjoint? So if not disjoint, that means that they connect somehow. That means that they intersect. So let's look at it in a Venn diagram. Okay, so if this is A, I guess I could have done a perfect circle. Okay, so if you have that circle there, let's go back to my original. Okay, so if you have, this is one event A, and this is another event B. Okay, so if you look at this, there's overlap. Okay, so what happens here is, now I want to find the probability of A happening or B happening. Now if you pay close attention, really pay attention, because or means it could be anything inside these. Anything inside. So this area here plus this area here. Well, let's start off with this. So if they're disjoint, you go ahead and you add this once and you add this once. Okay? And what do I mean by once is that's one shaded region right there plus the second shaded region. Okay, so now let's look at what we did here. What happens if they're connected? Okay, so let's look what happens. You're gonna add A. Well, this is all A. See this little section I'm doubling it in? That's all A. So you're adding everything in here, even the middle part. Okay, so that's adding A. Now take note, before I go on, this middle section right here, if you recall from earlier, that middle section is A and B. A and B. Those are the outcomes that are in common. These are the outcomes in common. I think I've done too many videos. I can't spell anymore. There we go. I think that's right. These are the outcomes in common in the middle, this little area. Now if you look, when you add A, how many times did the middle get added? Once. Okay, it got it added once. Now if I add the probability of B, okay, so let's change the color to orange. Okay, so I need to add all of B, which is going to include this middle section. Now I'm adding all of B. Okay, now if you notice, the middle now has been added twice. I added this probability twice. Okay, but the thing is I just want this region. You see how this is only shaded once and this is shaded once? Well, I'm inside here. I'm just drawing it again. If this is A and this is B, I want this added once, this area added once, I want this area added once, and I want this added once. So this whole thing needs to be shaded in once. So that area right there, this area right here, and this area added in once. So if you know all three of these, if you know, let's say this, I'll call that x. If you know this, and you know the middle section is y, and you know this is z, to find the probability of A or B, you would just add all the three. But sometimes you don't know that, okay? So sometimes, okay, you may not, well, you may know the and. Okay, so I'll show you kind of two different ways that you could do this. The notation is just a little confusing, but if you look, if I just need this added in once, this area here got added twice. And here, this area got added twice. So I only want it once, so I subtract it out once. So I subtract the probability of A and B. Okay, so that's one way you could do it. Now this is going to be really, really confusing because a lot of you guys aren't familiar with the notation. But this is good. You should know this. These Venn diagrams help out a lot sometimes with these problems. Okay, so I'm looking at this moon right here. I'm trying to figure out what this is. Okay, I'm trying to figure out what this section is. And it's good to understand this stuff because when you get into higher statistics classes, you do a whole ton of this stuff. Okay, so this is the event A and that's the event B. And I'm interested in this moon, this section right here, not the middle and not this over here, just this. Okay, we're going to do each one. So this is, okay, A happens, right? A happens in here because this is A. So A happens, and does B happen in this section right here? This is outside of B, right? So A happens and B doesn't happen. Okay, I think we've established the middle. I think we've established this middle already. These are the outcomes from A and B. So that's A and B. Now let's look at, I'll do it in orange. Let's look at this other moon over here and think about what the notation is here. Okay, so this notation, this moon over here, does B happen? Does B happen in here? Yes, B happens. Remember, I'm not in this inside part. So B happens. And does A happen in here? No. So B happens and A happens. Okay, so now let's look at this surrounding area outside of the circles. Okay, does A happen out here? No. So A doesn't happen. And does B happen out here? No. B doesn't happen. So neither happen out here. Okay, so another way to find this is, another way to find the probability of this, and you probably won't use this method, but it's nice to know. A or B, C, that's the red moon, plus the probability of A and B, that's the middle section, it's the middle section here, plus the probability that B happens and A doesn't happen. Okay, so that's just some good stuff to know. This is the formula that you're going to be working with the most. Okay, so let's look at this example. L, you'll get it more when we do an example. Okay, L is the event that the student lives on campus. M is the student participates in the meal plan. Okay, so the probability somebody lives on campus is 56%. The probability somebody has a meal plan is 62%. Okay, and this is the probability that they live on campus and they have a meal plan. You could ask yourself, are these two disjoint? And the question is, if somebody could live on campus and have a meal plan, then these events are not disjoint. If they could both happen at the same time. Okay? So I'm just going to do a Venn diagram. Venn diagrams sometimes help with the visual. And I'm going to do this being L and this being M. Now you have to be really, really careful, okay, when you're doing your Venn diagram. Okay, so I'm going to give you some steps. Start in the middle. If you don't get that, okay, you'll see in a second. Now L is this big circle. L is this circle right here. So the sum of the middle and this moon right here have to equal 56%. So how much is how much of L consists of the middle? Okay, isn't that 42%? Okay, isn't the middle 42%? Should have a different, a bigger middle here. Let me do this bigger. And I do it in not a great color. Do that. So this middle is 42%. See, this is both. That's and 42%. But L is 56%. Well, out of this 56%, 42 of it's being used already. Okay, so the remaining over here and this moon over here has to add up to be 56%. So 42, 52. I go up 10 and I go from 52 to 56, which is 14. So this is 14%. Okay, now the same idea over here. Well, this is the meal plan. What percentage of this big circle out here had the meal plan? Well, 42% already had the meal plan, so what's left to give you 62%? So 42 up 10 to 52 up 10 to 62, so 20% are there. So if you want, you could figure this out right here. Okay, the sample space consists of this outcome, this outcome, this outcome, and this outcome. If you add this plus this plus this plus this, you will get 1. That's every possibility. Okay, now you can see these are disjoint. I'm going to draw a dotted line here. See? This is disjoint from this. Okay? This middle is separate from this. These two are not connected. See, this right here is not, X is not connected to Y. They're separated by this line. Same reason, this outside area is not connected. So if I wanted to find the outside area, 42, okay, so it'd be 62 plus 14, okay, so 62, 72, up 4, 76. So this 3 here equals 76. So what's the complement of 76? And that would be 24. Okay, so now let's look at this one. I just asked you a nice and easy one. So let's use our formula. The probability of, since these are not disjoint, you could use this formula. And that would be the probability of L plus the probability of M minus the probability of L minus, not minus, L and M. Okay, so the probability of L, that's the whole L. So you didn't really have to do this Venn diagram here, but it's good to know. 0.56. What's the probability of M? 0.62. Minus what's the probability of live on campus and a meal plan? 42. Okay, so this would be 1 point, let's see, 5, 6, 11. I'll just use the calculator so I don't make silly mistakes. 1.18 minus 0.42. Okay, so that's your answer right there. Okay, so see, that's using this formula right here. If I would have used this formula, which you won't do, you generally won't use this one, but I would just add this up, which would be 14 plus 42 plus 20, and you should get the same thing. 42 plus 20, 62, 72, 76. So it works both ways. Okay, one more quick example. Let's do one more quick. I know these are starting to get longer, and I don't mean to, but this will be quick. I'll just go real fast. Police report that 78% of drivers stopped on suspicion of drunk driving are given a breath test, 36% a blood test, and 22% both tests. So if they could get both tests when they've been stopped, then they're not disjoint. They're not disjoint. Okay, so if they're not disjoint, we could use our formula. Probability of A plus the probability of B. If they were disjoint, you would stop here. But they are disjoint, so you have to subtract out the middle ones. That's the middle. So the probability of A is 0.78. That would be a breath. Probability of blood is 0.36 minus the probability of both, which would be 0.22. Okay, so 0.78 plus 0.36 minus 0.22. And if I didn't make a mistake putting that, you have a 92% chance of getting either test. So don't drink and drive. Find the probability of getting a breath test or a blood test, but not both. Okay, one or the other, but not both. So if you look at a Venn diagram, set it up. Start with the middle, 22. Okay, so this is going to be A, and this is going to be B. Start with the middle. This whole A right here has to add up to be 78. So you just do 78 minus 22. That's the complement of that, which would be 56. Okay, and B, and the reason I'm doing this is because you get a breath test or a blood test, but not the both. So you need to find all three of these and then subtract the 22 out, because I don't want this. I don't want that. Okay, so for B it's 36. So 22 plus what gives you 36? 22 plus what number gives you 0.36? That's how you find this area right here. So 22, 32. 32 to 36 is 4, so it would be 14. Okay, so that's that. So to find this, I'm only interested in this because they got A and they got B, but they didn't get both. So this is 0.56 plus 0.14. Okay, so 56, 66, 66 plus 4 is 70. Okay, so there's a 70% chance you're going to get one or the other, but not both. Okay, find the probability that they did neither? Well, you know neither is on the outside. So you can find all three inside, add them up, and subtract it from 1, because it's on the outside. And this, and this all add up to be 1. Okay, so it's, let's do it this way. I added these two already and got 70. Okay, so I added these outside two and got 70, so I'm missing the middle. So it would be 70, 80, I'm adding 22 to this. So 0.7, 70 plus 22, 70, 80, 90, and 2. So that's 0.92. That's all the inside. I got it right here. This is all the inside, so you just do 1 minus that. So there's an 8% chance you won't get either. So that means if you stop 100 people, and if this was true, if you stopped 100 people, about 8 wouldn't be tested. Whenever you do percents, you want to use the number 100, okay, or 1,000, and kind of do it that way. So anyways, I'm going to end now. Sorry it took so long. I'll try to start shortening up the next ones. Thanks for watching.